How's it going, everyone? Good to see you. Let's see here. All right. We're getting things going. Let me close this. That's why. All right. Okay. So what we're going to do today is we're going to try to get our Burn library to train data. That's the one thing. That's the one goal. We have one goal. I'm actually really excited. I want this to work. All right, let's make this work. All right, so where did we leave off? I believe we have it working with the current setup. We've got it working with the current setup. Yeah. So we're able to part through. We're able to run a feed forward on the data, basically. So we're good there. We're good there. What we need to do now is train it. So we have the model here. We've got the model defined. Let's see if we can. We don't need multiple activations. We could just do one activation here. I think we could do it something like this, right? Is that how we can do it like that? I think so. I think we can do it like this. And let's just keep it like that. Basically what we're doing is we're setting it up so that we have, hey, Quantified Quantum, how's it going? Welcome on in. Good to see you. The Steven branding is getting my head. I just read the title as Rust Blum. Did you? Yeah. Because the letters are pretty close to my last name. You got it. I know you got the Steven branding and yeah. Yeah, you know, I know what you're talking about. That's crazy. That's amazing. I didn't even think of that. That was not planned at all. There's no planning on that. So we've got our linear, although, okay, so we got linear 1, 2, 3, we've got our activation, and what we need to do is we need to update this here, so that way we can just reuse activation here. All right, so I think that should still work, and I'm understanding things better now in this library. I'm starting to feel more comfortable. After a few streams, we've been able to see how the Burn library works. Also, reading through some of the code here, we can see it's nice that they've defined some of the understandings of what the expectations are for the input data and the output data. I think that's a huge aspect to it. Hey, Justin Inc., how's it going? Justin CC, welcome on in. Good to see you. The Burn library in Rust is what we're working on today. We're learning it. We're understanding it, and we're going to be using it to do maybe some stock price data predictions right? So I'm actually kind of excited about it. The reason why I like stock price predictions as a task for AI to accomplish is because, nice. Hey, Techman, the Techman, good to see you. Welcome on in. I like using stock data because there's a lot of data, right? And so it gives you basically a full picture of data, right? You've got 100% of the data essentially, and you can then start augmenting information along with it. So that's what we're working on. That's why I like using it like that. So Blum, surname, has 2 root German or Jewish? I don't know. Does it? He's gone. Oh, who's gone? Wait, who's gone? Wait, Justin CC. Closing in Steven. I'm closing it. All right, you're getting closer. You're figuring it out. You're figuring it out. Just a step closer. All right, so I understand this. So yesterday, Nevo was here. Nevo was here and describing and understanding how these generics work and what it's expecting. So it's a tensor with the batch size and the class probability, which is the output size. And class probability is going to have its own other dimensions to it. I assume, I'm just guessing, right? Because you've got width and height and batch size. And so it has to be 3. And then you've got batch size and class probability, which is 2, right? So it's a 2-dimensional multi-rate underneath. I'm here. No, I'm here. You're here. The Techman is here. The Techman is definitely here. All right, so let's see if you can pop this in over here. Rust Day, you got it. It's Rust Day. Rust Day today, you got it. Sachin, hey, Steven, great to see you as always. Nice, Sachin, good to see you too. Welcome on in. And then Abhishek, good to have you here. Techmark, no, Techman, you're lying. All right, Techman, I don't know. I think Techman's telling the truth. I feel like Techman's telling the truth. All right, so we've got our input data. So it's a batch input. And then it will be should this be, no, it's not, because it's not 3 dimensions. Okay. This is the number of dimensions. All right. I'm getting it now. See, it's weird to me. Like I feel it's a weird aversion. So this is a tensor with 2 dimensions because you could have a 3-dimensional tensor, which can get pretty advanced, right? Of course I'm lying. It's an AI. You never know. You never know. It's gonna get us someday. It's gonna get us. It's coming right for us. All right. So here we go. Default device, probably the CPU, right? Print device. I'm actually kind of curious to see what that's going to come of it. Let's see if we can run it now. We made some changes. Not a function. Oh, it's not. Of course not. So is it print exclamation point? Wait, is it print ln? I forgot. Print. Which is it? Is it print exclamation point? Probably, right? Because it's a macro. We're doing a macro. What are we building today? Abhishek, we are building stock price. We're using the Burn library is what we're doing in Rust. We're using the Burn library. We're trying to learn the Burn library, and we've got one goal to train the Burn library on XOR data. And it's like my favorite Hello World because you can see all the data. You can see it all. Oh, it is MSL. All right. So is MSL going to be the metal? Is that what that is? Is that metal? Is that what MSL is? What? Oh, all right. Okay. It was just a joke. Just a joke. Oh, wait. Hey, Code Snap. How's it going, Code Snap? I just saw your message. Hi, bro. I'm really sorry to bother you. I'm a genuine emergency and need help urgently. I know you can have a small loan of 20,000 that I need to clear immediately, and I don't have anyone else to ask right now. It sounds like an emergency, Code Snap. Sounds like an emergency you got there. All right. All right. So we don't need to print that out. So we're printing out the out. So we did that. We need to learn how to train now. That's what we have to do. We have to learn how to train. So we're everything all in one file. That's what we're doing. So let's see if we can read some code here and see if we can train. So I know this is the model. So let's jump in over here. Is there a training? Here it is. Perfect. Okay. Oh, look at all this. There's a whole bunch of things in here. All right. So cross entropy, atom, optimizer. Here's the loss function. Data loader. We don't need this. We don't need that. What is compact recorder? What is that? I don't know what that is. What is this? There's all sorts of fun things in here. With file checkpoint. Okay, so that maybe it saves various versions of the model, so that way you can get the best one. Is that what that is? Is that what it is? I don't know. Is there something we can do on Python as well? Sachin, you're absolutely right. You can do this in Python. You use the PyTorch library, the libtorch. You could absolutely do that. We're using Burn, which also supports libtorch as a backend. We're just doing Rust because I'm feeling a little rusty today. Sorry, I don't know Rust, but hope I will learn something new. All right. It's all the same sort of logic and when it comes to the AI models themselves. It's all the same, basically, across no matter what language or what framework you're using. They're all the same, right? It's all basically the same. Oh, neat. There's a shuffle. There's a nice little shuffle command. You want to reshuffle every epoch, though. I say always reshuffle every epoch. I don't think you should shuffle once and then just keep training on that same shuffle. I think you should reshuffle every single time. It's almost Christmas. You should go get a tree in the background, Stephen. Well, we could turn the background into like Christmas colors. We could do that. It's not as pretty as a Christmas tree. Maybe we could definitely do that though. All right, see here. All right, so data loader. All right, so where's the build? All right, so learn builder. Oh, look at that. There's a learn builder. All right, the learner. All right, learner, fit, result, train data, where is the model? Where's the model at? Where do you specify? All right, build, model, init. All right, optimizer, learning rate, learning strategy, single device. Okay, interesting. Oh, neat. All right, so there's some nifty stuff here. We can copy and paste some of this. We probably don't need the metric validation. We probably don't need these metric things here. I don't think so. We do need the loss, though. So we probably need some of it. So we probably don't need that. Although, we'll find out. Have you ever went to Oregon Trail Middle School? Oh, in Olathe, Kansas. I've not been there. I've not been to Kansas. I know of Kansas. I know it's a state, right? It's a state in the U.S. I'm pretty sure, right? It's a state. All right, let's see. Let's keep going here. So I want to. All right, training config. Do we need this? Is this something we need? It would certainly be nice if we didn't have this little pop here. This is a lot of stuff. Model is here too. Oh, we're implementing the model. Are we doing create? Okay, here's the model. Got it. Okay. Forward classification. Output. So okay, got it. Understood. Okay, so we need to define a forward classification, which is going to be used to capture the output. All right. And then we return a new class out with the loss, the output, and the targets. Okay. I got it. Everyone should subscribe, right? I like this guy. He's really cool. All right, the tech man. Thank you for saying that. That's great. That's a really good compliment and also a great advertisement too. Right? Definitely. We're making things happen. We're just learning today. Is what we're doing. We're learning. We're understanding how the Burn library works. Auto diff backend, huh? Is that what this is? All right, let's step in. Train step classification. Wow, that's a lot of stuff here. Oh, okay, got it. Here's the step. Okay. So this is going to be, is this accurate? So this will run the output classification from above. And then, oh, did we run out of, did our mouse run out of battery? I think our mouse ran out of battery just now. I got to plug in my mouse. I was not expecting it. 1 second. The mouse, 1 second. All right, 1 second, you guys. I'm going to plug in the mouse over here. It ran out of battery. All right, just got to plug in the mouse over here. Here we go. Pulling this. All right, here we go. So the battery got to replace. Got to power the battery. All right. Man, I miss these days where we had the fun while coding. I know, right? Blasi, you don't have to give it up. You can keep going. You can why stop now? What mouse do you use? It is a Magic Trackpad. So it's just a giant slab that sits on my desk. It's a giant slab that sits on my desk, you guys. Giant slab here. I like it. I like it. Giant slab. These days I feel like robot while coding, isn't it? Because the AIs are coding all for us. They're coding all for us. I always do the everything faster, and that requires AI. AI goes a lot faster than a human. It can go, it types really fast. It types it all, and it makes it really. It does a really good job. Although I want to keep my skills up to date by constantly, making sure I've got all the skills and memory and things like that. So. This is a lot to train. It's so much easier to use PyTorch. It's so much easier to use PyTorch. It's ridiculous. All right. Data loader. Where do we post the data? Okay, data train, learner fit, loader train, data loader test. Okay. Do we need two things here? We got to do test and loader at the same time. How does shuffle work? Oh, config seed. Okay. I was actually going to say, because I'm like, you can't shuffle the two data sets separately. You have to keep them in tandem. Are we not doing what we did for stock prediction? Yep, that's what we were doing. Geechee Man. Geechee Man is here. What's up? Hey, Geechee Man, good to see you. We are definitely doing the stock prediction, but we're trying to get everything set up. It's not an easy, quick, simple setup. So we have a lot to do. We have a lot to do. I want to just train it. Why does it have to be so complicated? Valid step back in. So what do we need here? We need this. I know we need this part right here. So let's go ahead and copy and paste this piece right here. Let's copy and paste that and put that into our code over here. So because we need to implement a classification thing here. Sorry, set paste. All right, set no paste. No, I don't know what that did. Set no paste. Perfect. Okay. Here, what we got here? Model. All right, model. Good. All right, back end. All right, so this is the input. This is the targets, right? Input will be 2, I believe. Targets is going to be 1. What is this? What is this right here? What is int? What is int? int. What is that? It's just there. It's just there. I don't know what that means. Is it a, it should be a float, right? I assume it's a float. Okay. Do we have to, does it have to be an int? I mean, it should be. It should be. Here, you know what? Let's do that. Let's make it an int and let's turn these off. These will be ints, not floats. I assume. I don't know. We'll find out if that works. I don't know if it will or not. Make things pretty. All right. We made it pretty. All right. So now we've got this extra code here that we need to make sure. Ross, output, forward. Yep. This will be the input. Input. PUT. Okay. Input targets. All right. All right. Do we have this? I don't think we have to define. We have to define that. All right, let's define that. Where is that at? Where is that at? Hold on. Right here. Let's import this. Oh, train. All right, we got to do a whole bunch of train stuff here. All right, let's go ahead and copy and paste some of this here. We're going to copy and paste this stuff. Oh, wait. How do you use trackpad? My guy, I find it really tough to use. I have just been using it for more than 10 years. And I'm really into it. Because it's like a laptop, right? So on your laptop, you've got the trackpad on the laptop. And I got really used to that. I got really used to it. And so when I, went into desktop mode where I've gotten that, I just wanted to keep that going. The mouse, don't get me wrong, the mouse, way better, far more accurate. You can play games way better with the mouse. Whenever you launch your computer IPO, company's IPO, I need to have early access device shares in the earliest. All right, the tech man will let you know. We'll let you know when the IPO happens. We'll let you know. No, you're probably interested in other details beyond that. Though I don't have any. I don't have any for you right now. Set paste. All right, let's do this really quick. All right, so data. Okay. Is this correct? Here, is this correct? FCon. There we go. All right. Yes. Okay. Set no paste. Paste. There we go. All right. We're just organizing everything here. All right. So probably do this. Probably have use Atom config, whatever. We don't need Prelude again. I don't know what that is. So let's just hide that for now. I don't know what that is. Auto diff backend. I don't know what that is either. All right. Train classification, linear builder, linear strategy. Wow. There's just so much stuff here, you guys. There's so much stuff. I can't believe it. All right. We probably don't need all this. All right. Hide that. I know we don't need this either. Can I do MSE? Is there like an MSE? Because for what we're doing, we don't need we don't need this. We need something else. Can we do mean squared error? Is there something like that? I assume because it's all right. So you can do mean squared error. Is it like I assume? I don't know. We'll find out. We'll find out, you guys. Once I'm able to invest, have good money, I will definitely invest in your company. Because, of course, if you are, and it is definitely going to grow. Yeah, right? It's working, right? We're growing. We are growing. That's what we're doing right now. It's a thing. It's real. Not for pretend, like we really are. We're doing good. We're doing good. All right, so let's keep going here. All right, so let me build that. Let me see. Is this good? I don't know. Actually, I don't know about this. I don't know about that. That's fine. We know that works. This, I don't mind about that. Do we always have to reinitialize every forward classification, the cross entropy config? This seems like a problem. To do cache in model. Well, maybe a model training struct or something like that, right? We probably want to do something like that. Because why continuously for every single output reinitialize the config for the cross entropy loss? Like, why do it? Because you have to, and then you have to put it to the output device, and you have to forward it, right? Just create it once. Or does it always need? You always need to do it. So classification output new, like this seems wasteful. It seems wasteful. Why do I feel like no one here today? I don't know. I don't know what's going on. I think maybe things are slowing down. I don't know. Like I've been looking at the numbers and I'm like, I don't know. Hey, Matthew, how's it going, Matthew? Good to see you. Or welcome on in, Matthew 672. All right. So I don't know. I don't know. We'll see. We'll see how things go. It might be something. I've been looking at the numbers and I'm like, I'm not seeing the same numbers. Although, you know what? It could just be a lull. It could be something else. Could be a change in the algorithm. I don't know. It could be we're doing something different. We'll find out. We'll keep trying. Let's not give up. I think the idea is persistence. We got to keep persistent. Hey, Steven, great to see you again. Hey, Matthew, good to see you. Welcome on in. We're working on the Burn library in Rust. I wanted to get up to speed on it. All right, let's see. I don't think it's going to work here. Okay, good. All right, so we get a bunch of warnings. Perfectly fine with that. Perfectly fine. We don't care about the warnings. The thing we care about are the... Okay, so this doesn't exist. Here, I got you. What we'll do is we'll just merge that back in over there. So that way we have something that's good and known. Okay, so it's building. All right, so far so good. Hey, Stephen, how are you? Hey, DX Knee, Dusted. We're doing good. Thank you for asking. We're doing very good. Thank you. We're learning we're working on Rust. Isn't it a good day when you get to work on Rust? Just vibe coded it? Did you? Wait, vibe coded what? Hey, how's it going, Mohammed? Welcome on in. Good to see you. Happy to have you here. We're doing more Rust today and machine learning, Rust machine learning AI with the Burn library. And that's what we're doing. Nice, yeah. I think that algorithm is focused on sponsor due to it's holiday season, right? The holiday seasons and all the shopping craze. You're right. You're probably right. It's all probably focused on advertisement dollars for people who are doing, what do you call it? It's like QVC or Talk Shop, right? Where they sell you products, right? They're like, look at this beautiful phone right here. Ooh, it's a beautiful phone. It's only $999.99 or 3 easy payments of $333. It's your choice. No problem. Right? We could sell anything. We could sell all of it. And so that's probably what's going on right now. That's a good one, yeah. Yeah, I know the site Roblox. Yeah, of course. I helped me code some stuff. All right, Lua programming language, the best embedded programming language. It's my favorite. I love Lua. We use it all the time. Why does C++ use : instead of just a dot? It's so stupid. I know, right? Isn't it? It's just, let's just use one. You have to hold shift, and then you have to hold shift and go : or you could just press the dot button, right? Easy. Instead of 3 buttons or 1 button, which is better? Simplicity. How's it going, Shadow 1K 5? Good to see you. Let's see here. So we got it running. All right. So we've pulled in some library stuff. All right. Let's see if we could go a step further. All right. So we're doing this. I don't know if it works or not. We're gonna have to mess around with it. Do we need this? I guess we need this, don't we? We need this, don't we? What is it? For model. Okay. For model. Good. Okay. All right. Let's just copy and paste this here. Let's copy and paste it and see if we can continue our build. All right. So where did we put that? We put that over here. Where was that? Oh, forward classification. Okay. Set paste. Set paste. Are we not? Let's see here. I just said here, all of a sudden is a massive burst. The algorithm is listening. It is, right? We get a bunch of unexpected. Hey, how's it going, everyone? Good to see you. Welcome on in. All right, you guys. Are we doing it right? Are we doing it correctly? Set no paste. All right, we're good to go. Is it going to build? Okay, we got an error. We'll be able to fix it. We'll fix it. Oh, mnist batch. Okay, so we know we're not doing anything with that, so we're going to have to figure that out. Auto diff backend not found in scope. We'll probably have to fix that as well. Is that because we commented it out? Here we go. We commented it out. Let's just bring the stuff back. This doesn't exist. That's not a real thing. We need a different, this isn't going to work for us. We need something different here. To do MSE. We need MSE, you guys. We need MSE. Yeah, because for what we're doing, it's not going to work. For the real, it's just, wait. Oh, the double colons is just, yeah, I know. It should just be period. It absolutely should be. You're totally right. It absolutely should be. I'm with you on that. I'm with you. In this case, the double colons, you could just do that, right? Just put that dot there. What's it? Dot, right? Oh, there's another dot. Oh, there's another dot, right? There's another. You don't need the colons. It's a dot. It's a dot. You're fine. You're absolutely fine. All right, let's see if we got rid of some of the errors here. Let's rebuild. Obviously, we didn't fix everything. So we're not doing mnist. So we need to... all right. Where I see mnist. Okay, see mnist. Okay, data set. We are mnist batch. Can we do something different? This is very unfortunate. Darn. All right, I'm unfortunate. I was playing with Rust an hour ago. Nice, and it found you again? All right. Hey, it's great to have you here. Hey, Nevo. How's it going, Nevo? We're making a little bit of progress. We're making a smidgen of progress on the Burn library in Rust. Python is the language of AI. It really is, Mohammed. It really is. You got it. Where's Jonathan? Right? I know. Where's Jonathan? Want to send him a PayPal, bro? Too much leftover money. So much money. I know. Jonathan was just donating like crazy. Remember that? Over multiple streams. Like, oh, a smidgen. Like, whoa. You should admit that. I know, right? Let's see here, you guys. All right. So we've got a problem here. I don't want to do MNIST. I want to do my own data set. Why does it have to be this hard? And why do you require to set a generic here when you're implementing a function in a model like this? When you're implementing a trait, why do you have to specify the data over here? This is the problem I have right now. The problem with like these abstractions, it takes it too far. Because now I have to do all this extra work to satisfy the abstraction. It's like labor. It's extra labor. What are you stuck on? So right now we're getting training. So the goal for today, Nebo, is to get the XOR. So here, we want to train on this data. Check this out. All right, so we mostly have everything good. So we want to train on this data right here, right? Simple XOR, is that correct? Yes. 0011100, perfect. So we want to train an AI model on just this. We're just trying to keep it simple. A very simple XOR. Completely agree with you. Yeah. Simple XOR. That's what we want. A simple XOR. What we need to do now is implement something with the train step and a batch here, which is really confusing. So I don't know how to deal with this. This is where we are. Yeah, Burn API is weird. I don't get it. All right, that's where we're stuck too. I know. That's what we want. So the MNIST batch, we need to change it with our own batch, essentially. With our very own batch. I upgraded these things, I assume. I don't know for sure. I wonder though. I wonder. Here, let's comment some of this stuff out real quick, so we can see if we can rebuild this. I want to test something. Really quick. All right. Looks good. Just a bunch of warnings. We're all good. Okay. All right. So forward. Where is that at? Here we go. Forward. All right. The output. I wonder if we could do 1, int. Is that what we can do? Is that the same thing, or is that different? No. Okay. All right. So this is something else. It's not what I thought it was. It's kind of that you streamed when it's midnight. Oh, it is. Yeah, I know, right? It's pretty late. It's pretty late over there, and it's early in other countries. So it's like late and early all at the same time. Late and early all at the exact same time, which is maybe part of the problem. We'll see. We'll find out. Also looking for a contributor because I'm gonna grind for like 30 minutes to implement a hot reloading. Oh, for dev mode, nice for the server's Discord bot. That sounds excellent. So that way you can keep the bot active and live, and then it can just reload any code changes that you have. Do you need to actually change it, Kyle? Because you will be passing in new data with the same types. Maybe. I mean, it's a different shape. So here, check this out. The shape that they're looking for is batch width and height, right? So it's a 3-dimensional array. And the output that I have is, and that's just for, right, that's the input. And the output will be batch and then a single number, and then a single dimensional array. So that'll be 2. However, they seem to have it different. What we could do though is I guess we could try it. Create MNIST batcher. All right. So what we could do is, since this is in the local crate, we could probably snag this. So this is another file. Let's grab this. All right. So MNIST batcher is what we need. MNIST batch and MNIST basher. All right. We can grab that. It should be in somewhere in here. Data. Was it in data? Hold on. Let's go back. Where was that? In for training. Here we go. Data. It was. Okay, so it's in the data file. All right, it's in the data file. Let's see. Data.rs. All right. So if we copy and paste this and then make it to our own means, we should be good. So let's do that. Let's copy and paste this here. Let's copy and paste this over here into our file. And then we should be able to update that and make it good. Is what we should be able to do. All right. Perfect. All right. Okay. look for MNIST batch. It's fine just to reuse it. That's what we're doing. There we go. Nevo, we're on the same page, you and I. We're on the same page. We're making it happen. All right, so MNIST batcher. So this will be image. So I do believe it's going to be inputs and targets. Fine. 2. I don't know what that is. And then 3. Is it 3? No, is it 2? Is it 2? Wait, where were we? I do believe it was 2 and 2. I don't know where we is. Is that here? Oh, batcher. Okay. I want to. So is it actually? So this. I'm assuming it's this, right? I assume, right? So this is okay. Where was it? Tensor metal back in 2 looks good from data. All right. I want the model config. No, the actual model. Where's that at? Where do we put that? Where do we put it? Is it around here somewhere? Here it is. Okay. All right. Forward, right? So 2 and 2. Perfect. It's 2 and 2. So we should be able to change that, and that should be good. So where was that at? Here, 2 and 2. That's what I thought it was. All right, so it's batch size, and then, right? So it's 2-dimensional array. We're dealing with 2-dimensional arrays. We're looking at the 2-dimensional arrays there. All right. Nice, easy, relaxing jaunt with the Burn library and Rust. So we don't need to do any of these normalization steps. Also, I guess this is data pre-processing, right? We don't need to do any of that. None of that needs to happen here. Images, items, targets. So we could probably, all right, so this is what we got to do. Okay. MNIST item. Where did this come from? Where's this at? Oh, great. Now we got another abstraction to deal with. Come on, guys. Let's see here. Also, we need to see, where is that at? All right, so vision MNIST item. Oh, okay. So this is just part of, it says data set. So this is just extra data, right? That comes with the library for, testing purposes. How do we deal with this? Items, batcher, items, device. All right, so device is fine. MNIST batch, MNIST item. So we've got this. We've got this class. We're good there. Or the struct, rather. We got the struct. MNIST batcher, which is empty. Just empty. How about we... Let's see here. Yeah, you just need the collect. All right, cool. Just the collect. So we could just delete the rest of this. Boop. Like that, right there. Boop. Like that. Targets. Wait. Hold on. Items. Wait. Items. Wait. No, this was wrong. This is wrong right here. That seems messed up. Hold on. Okay. So our targets is going to be different. This needs to be different. We can figure that out. This is fine, right? So this will be input, inputs, images, tensor, cat. Okay, images. All right. Targets. All right. So, okay. All right. We're figuring it out. We're figuring it out here. I'm not label. All right. So we don't need to do any of this extraction. I mean, look at this ridiculousness right here. Do you see this right here? Isn't that ridiculous? I think that's ridiculous. That's a bit much for a human to have to deal with. That's what a computer's for. Great, man. The slightest of help goes so far. Nice. Steven is locked in. I'm attempting locked in. I'm attempting it. I'm complaining right now. Is what I'm doing. This right here, look at this. Who would know what that does? I understand it kind of, right? So, we've got something to do. Like it's a tensor, and I believe it's going to be 2. I think it's going to be 2 like that. Although we don't need that. We don't. So where's this batch? Okay, so a batch is going to deal with a set of items, and then it's going to return both at the same time. Where do we run batch at? Okay, so we run batch. We run step batch MNIST batcher. Okay, so let's give this batch images and targets. Okay, which is going to return a struct. So where does this get the batcher? Here's the batcher for MNIST batcher. All right. Okay, where is that at? So, all right, so this is struct. Can you maybe copy the code, put it into the AI and ask. Yeah, we totally could. You're absolutely right. We could. That's something we could absolutely do. We could ask the AI. You're right, the tech man. All right, because you asked the tech man, we're going to ask the AI. All right, let's do it. Let's copy this right here. Copy. Well, this one. Here we go. There we go. Copy. Wait, no, we got to copy it right. That. Okay, there. All right, it's copied now. All right, so let's go over here. Let's go over here. Explain. Here we go. Watch. We'll do this. Here we go. Watch this. Because you said the tech man. Explain the Rust code. All right. Let's see what it says. All right. Yep. Item.label. Obviously, I know what it's doing. It's abstracting the label data, the output data from the image set, right? It's going to be a class. It's going to be a class between 0 and 9, right? So it's a 10 possible classes. I know what that is. This creates a tensor using a backend B with a rank 2, two-dimensional tensor. All right, so we figured that part out, right? We know what we're doing. B usually something like indie array, GPU, and burn auto diff. All right, so that is going to be the backend B. All right, so what device is it going to run on? All right, we got that as well. 2 means the tensor must behave like as a matrix, even if it's 1 by 1. Got it. All right. Rust is the learning curve. It's a cliff. It is. You got it. It's a cliff. All right. Quantify quantum or vanish. We'll see you here in a bit, or maybe a little bit later. Sounds good. You have data samples, right? That goes instead of the. And yes, you're right. We do. Nevo, we do. You're absolutely right. We could just print out the data samples and inspect it that way as well. And we can inspect it that way as well. You got it. All right. So this is just conversion, right? We know that float conversion, easy. Element, int element. All right. So where was that? Was that here? See here. Was there something like that in here? Oh, right here. All right. So here's an int element. All right. Let's pull this up here so we can see it. This converts a Rust primitive I64 into the backend specific integer. Oh, really? What do you know? All right. Sounds good to me. Makes sense, I guess. Backends often have their own element types, GPUs, quantifiers, and things like that. Ensure the number is turned into a B int element so the backend can store it. This wraps the element in one element or Rust array. This triple dots. Okay, so where were the triple dots at? Did we see triple dots? Is that even in here? Was it? Is it hallucinating? 'Cause I don't see it. All right. Is that here? Okay. Let's grab that. Go like this. Okay. So here's this. I don't see any triple dots. All right. Sounds fine with me. Device. Okay. Label, convert, pack into a 1 element array, creates a rank 2 tensor array. Okay. I mean, it helped a little bit. You're right. It helped the smidgen. It did. We helped the smidgen. Triple dots is never a thing. Oh, got it. You made it. Hey, how's it going, Kyle? Yo, you made it. All right. Good to see you. Welcome on in. We're working with Rust today, and we're learning the Burn library. That's what we're doing. We're learning the Burn library, you guys. Like, not in this context. No, right? Got it. Yeah. Triple dot. Yeah, there's no triple dots. There's no triple dots. All right. So we've defined this, right? Oh, no, we didn't. That is coming from a data class here. So we could just grab it, I guess, and then inspect it. Like Nevo is describing, we should grab it. All right, where's the data? Data over here? Okay. All right, so we grab data. Let's pull this out here like that. I believe we can go like over here. All right, so we grabbed our data. Data loader batcher, data set here. Do we already have the batcher? Implement batcher for MNIST. Okay, so we needed that. We needed that anyway, so I'm glad we grabbed that. I'm glad we grabbed it. Okay. Could we, I suppose we could keep all of this here, but I don't want to. This is going to be rough. This can be rough. Okay, I think we can do it. You need your own because you're not doing images? Yeah, we do. Neville, you're absolutely right. We absolutely do because it's a different dimension. Like the class. Oh, have you tried using AI to transfer Python projects to Rust yet? Oh, I have not. That's actually a good idea, Kyle. It is just easy transcription. Have the AI translate the code to another language. There you go. Nice. Like the class is made specifically for image plus label. Yeah, it is. You're right. Exactly. So we need to redesign our own. So let's see here. Backend, batcher, imness item, imness batch. So this is the data itself. And this is, I don't know what specifically it is. So we're figuring an imness item. So this will iterate. So this creates the batch, I assume. And it looks like this creates, it says images and targets. Is there a batch size in here? Are we seeing a batch size? I don't see a batch size. App becomes a part of my routine to drop in here before I sleep. Hey, nice. Hey, that's great to hear. And part of your nightly routine. It's part of your nightly routine. Sounds like that's what I like to do too. I usually pop in on some of my streamers before I go to sleep. Hey, Steven, any suggestion which model is good for writing unit tests, specifically for Python code? Are you talking about a large language model? Is that what you're doing? My go-to is Claude. There's also Codex, right, with OpenAI. That works pretty well as well. Claude is my go-to. It's always done great for me. Claude's always been fantastic. It's always been fantastic. All right, so we're going to struggle now. All right, you guys ready for some struggling? Here we're going to struggle. We're about to struggle. All right, so do we see, this is the part that I'm not sure about. It's this here. Like, how do we deal with this? Oh, see, like, I don't even know where to go from here. All right. All right, let's see if we could, let's see. Batch size isn't a generic. Okay. Pub struct imnist item image float pub image f32 with height. Yep. Label of the image. Yep. Which is a U8 because might as well be U8, right? 256. That's all you need. Claude Sonnet 5.4 is not that good as there are multiple dependencies in these mocking and patches breaks the other parts of the tests. Oh, really? I didn't know about that. Have you tried the new Opus 5, I believe, or something like that? Obviously it's only just a step up to be a little bit better. It does a pretty good job for me. Try Codex or Gemini. I mean, that's the only thing I can recommend. Just try different ones. They're all a little bit different. It's very weird. It feels like they all should be the same at this point. They're not. They're not all the same. Or try Brock, right? Try Brock, try Gemini, try other things, and then see how it works. That's my recommendation. All right, let's see here. So we need to. All right, so where's items? Okay, targets. So items is going to be a vec of. Can we just say F64 is what we're going to do here for the batch. I suppose we could. Can we do? Where's batch run at? Let's see, batcher images. So this just returns. Where is it? Step batch. Where is it at? So is the batch function even run? Is what I'm looking for. So here's the definition of it. Not tried Opus. We'll try it. Shirley, thanks. All right, sounds good to me. Have you tried Claude in the CLI? Yeah, Kyle, I love it. It's my favorite. I use it all the time, every single day. Honestly, U8 is weird. It adds nothing to the code because structs align. Oh, right. With the 32-bit anyway? Yeah, that's right. You're using the memory anyway. Why do a U8? You got it. You got it, Nevo. Exactly. The compiler, when it compiles down to the assembly, the assembler is going to have an alignment. The alignment is going to be 32-bit anyway. It's not going to be 8-bit. You're not going to stuff a whole bunch of data right into a bunch of 8-bits. So you might as well be 32-bit. I'm asleep now. Cool, the tech man. Thank you for stopping by tonight. Good to have you here. Good to have you here. Enjoy your sleep. All right, let's jump back over here. If I build this, it's just going to be a flood of errors. All right. Where's the batch function called? That's what I want to know. That's what I want to know. Batch.targets, batch.images. Have plentiful rest. Yes, absolutely. Good to sleep. Sleeping is nice. I want to be sleep all right now. It should be literally identical to the 32-bit case. It is. You're absolutely right. It should absolutely be. I think so too. Well, I mean, not only I think so, I'm pretty sure, and it probably actually is. Like, just thinking it out. All right, so F64. All right, so I do batcher.batch. Self is going to be imnus batcher, which is here. We're just creating a batch function here, and the problem is I need to see where it's run so I understand. So then I can understand. See, there's a step here, and then we're getting another batch. So what's happening here? Why is this basically defined twice? What's going on? So valid the step, train the step. Okay, so this is the training step, and this will be a validation, which does the forward classification again. Okay, so this will be for the test data probably, right? So that's the test data. Okay. Train step. Sounds good to me. Figure this out here. Oh, sad. Okay. All right. Where do we go from here? This is what I want to know. Let's read some more code. Let's go back over here and read some more code. Hey, MD, how's it going? Welcome on in. Good to see you. And that one you ate. Oh, wait. Nebo, what do you mean that one you ate? Hey, MD, good to see you. Welcome on in. Happy to have you here. All right. So we're struggling to get the Burn library to work. The challenge with the Burn library is it's just the amount of code you have to write in order to use it is over much. It's a bit too much. Important. You need to have the input and the output. Yes, exactly. Yeah, we need the features and the labels. Yeah, exactly. We need the features and the labels. So what I could do is I could just merge the data when I'm throwing it into the batcher. The thing is, where's the code being called? Like, where is it happening at? Like, I'm not seeing it in here. Like, where is it happening? So I've got this. We could just, what we could do is say features labels or something like that. Or we just merge it together. We can just merge the data. So that way the first two elements of the array are the input data and the third element is the output. So that way each item, as you're training each sample, will be in the same shape. So that's what we could do. We could do that, right? So here we go. So let's do input output. So let input in output, like we could combine these, right? So let's say in out. Let's keep it like that. We'll just copy and paste this here. There we go. And then instead, so we'll say 0, right? 0, and the next one would be 1. Here, let's make it pretty. Let's make it pretty so we can see it easier. Let's make it pretty. I'll make it pretty. F. Here we go. Dot. There we go. Make it pretty. Make it pretty. Okay. And the third element. So this is a 1, and then this will be a 1, and the last one is a 0. All right. Perfect. Here we go. Okay. So we've got the in out. Works for me. Now it's in the right shape. That will work for the batcher that's expecting all of it's all in one spot. But you always also work, both are fine. Then you can loop iterate, have items be items input. Oh, input and output. Oh, got it. Yeah, that could work. Yeah, that could work. We could do that too. I like that idea. Neville, your idea is better than mine. I mean, I was doing like this. Your idea, I like your idea. So we can create a vector with input output, and that would, let's look at it over here. Where is that at? Item. Oh my goodness. So this is a problem right here. Where is that located? Yeah, now the parts that I do not get are this implementation of the trait. So I guess we're stuck. I call this being stuck right now because I don't know where to go from here. I suppose we could just not do this right here and we can just do the MNIST. Let's just try to see if we could do the MNIST. But then we have to redefine everything. It's not what I want to do. Take them as a tuple. We could do as a tuple. Yeah. See, I would love to do that. The problem is, where would, I guess right here is what you're thinking. So items could be like this. Is that going to work? See, the thing is, I don't know where, right. So I think this is what you're saying, right? Tuple vec, F64. And then there you go. So we got items like that. That'll work perfectly fine. I'm perfectly fine with that. The challenge is this function is not being used anywhere. Batch. It's just not used. It's never called. It's never been called. So I don't know where to put that data in. That's part of the problem. Let's see. Inference. So, all right. So we don't need to worry about that. Data. Let's see here. All right, see if the batch is in here. Batch. Nope, that's just where we were. All right, so not in data. What about lib? What's in lib? Nope, nothing in there. Hey, JG, thank you for the jewels. Well, that was unexpected. We got a whole bunch of jewels going over here. What is that for? Why are you doing that? What are you doing all the jewels for? I appreciate it. So I feel like you took over the chat window. You took over the chat window, Jay. That's amazing. Thank you. Thank you for doing that. I was not expecting that. Let me see here. Does it look? Wow. Look at that. That's great, Jay. Thank you. Thank you so much, JG. Thank you, JG. I appreciate it. Oh, never mind. The trait requires that it's making one vector for some reason. Is it? Has to be vec input. That's what I want it to be too, Nevo. I want it to be that too. JG, thank you for the jewels. That is very wonderful for you to do that. I appreciate it. I appreciate it because that says that, hey, we're on our way here. We're making things happen. We're making things happen. Batch. We're looking for the batch. Oh, hey, here's batch size. I've been looking all over for that. Where'd that go? All right, training config, batch size. Oh, where's the batch? Batcher default, batcher.clone. C, okay, validation step, batch. It's just so much code. And I do not, all right. Here's what we're going to do. How much time do we have left? All right, so we've got about 15 minutes or so. What I would like to get something that is at least working. So what I'm going to do is I'm going to clone this. I'm going to clone this repository, and then we're going to make our way into this directory, and then we're going to build this project, and we're going to train it. So that's what we're going to do, and then we're going to see how it works. I think that's the next step because we want to keep moving forward. We don't want to get stuck. So let's at least make some progress here. Perfect. Okay, so what we're going to do is let's go to the main branch. Let's see, and there's examples. We got all these pretty beautiful examples in here, right? We got all the examples, so let's clone this repository. Make it 20 and we have a deal? All right, Kyle, we'll make it 20. We got a deal. JG, again, thank you again for all the wonderful jewels that you sent over. Unexpected, but absolutely wonderful. Let's see here. Let's go over here. All right. New window, please. Thank you. Git clone burn. So we'll throw that into the burn directory. All right. ls cd burn. All right. So let's do cd examples. And then there's a readme in here. I think there's a readme. No, there's not a readme. There wasn't a readme. I thought there was. All right. ls. Where was it? ls. No, ls examples. So I guess cd. I guess we could just go into the MNIST directory. Well, let's go to the MNIST directory because that's like the traditional hello world, and it should give us a little bit more details, right? Examples MNIST. MNIST, please. Thank you. All right, via README. All right, so if we run this, that'll run on, features on the CPU. All right, Torch GPU. I wonder if we could throw it on the Metal or export CUDA. Okay. We do not have CUDA, so we cannot use Torch, I guess, apparently. We can do indie array. This should work fine because that's just CPU. It will take a long time to train, though. I think it's just a little bit longer time to train. All right, so let's see if we can run this here really quick. Hold on. All right, let's see if that works. Let's see if that works. All right, so we'll compile it, and then is that going to build it? Hold on. Is that going to build? Oh, wait. Are we going to build or run? Are we building or running? I forgot. Oh, we're running. Okay. So this will build and run it all at the same time. Let's see what it does here. And then we can look into some of the code. All right. While that's working, burn examples mnist ls vi. WGP would work. Try it. Okay, we'll try WGPU. All right. That's a good idea. Let me this is for WG. Okay. Use this. All right. So we'll try this one right here. We'll try this one right here. That's a good idea. All right. We'll try that one. Okay. So we'll let it finish building. We'll let it finish building, and then we'll use WGPU. Web GPU should definitely work. Cross-platform accelerator. Oh, wow. Oh, hey, look at that. Oh, whoa. Isn't that pretty? Okay. Do you guys see this? It was unexpected. Look at that. That's very pretty. All right. If this is what we get, I am kind of into it. I'm kind of into it. All right. So this is, what are we looking at here? We're looking at accuracy. Can we change it to something else other than accuracy? Loss. Okay. So that's the loss, learning rate. Can we see the learning? All right. Cool. All right. So the learning rate is probably going to, is it going to asymptote? Are we going to see an asymptote on the learning rate? All right. Here's the loss. So that means we're still learning. And we got our accuracy here, which probably improves over time, 44%. All right, looking good. Let's try WGPU. Let's try WGPU because this is taking forever. Close, please. Cancel. Cancel, please. Cancel. It's not canceling. All right, let's see here. Close, close, close. Yes, cancel, please. Where is there? Q. Okay, Q for quit. All right, I'm pressing Q. Yes, Q, stop. Stop training, K. All right. Whoa, what's going on now? What? Whoa. No. Q, K. All right, there we go. Okay. All right, let's try it. WGPU. WGPU. Let's try WGPU. Okay. It's got to rebuild everything now. We're going to rebuild all of it. Okay. Let's see here. Okay. Let's see where we get. Let's see where we get with this, you guys. Let's see where we get. I'm actually kind of excited. It should build a lot faster, and we get a very. I was not expecting that. I was not expecting to see a wonderful user interface that shows a beautiful display for the current accuracy, the training, the loss, and the Rust being very fast. Yeah, I know, right? It's very fast. I mean, it's as fast as it can be, right? It can't get any faster. The tension. I know, it's the tension. It's here. It's only one library away from building. All right, let's see if if we're gonna get the WGPU on it. We'll see if we get WGPU. Kyle. I mean, it'll be a little bit faster than, say, Python for sure. And it was working. And it was training on the MNIST data set. So, I mean, that's quite a bit of data. Let's see if we can get the WGPU going for here. Let's see if we can get the WGPU. All right, so is it gonna work? I mean, it's trying. It seems to be trying. All right. Let's see here. HTOP. Let's see what we got. What are we running here? What are we running? It looks like it's trying to do something, I guess. Or it's not working at all. That's one of the other things. It might be working not at all. Oh, there it goes. Okay, it just took a long time to set up. Oh, that's a lot faster. Hey, we're doing it now, aren't we? Oh, and it's using all my CPUs. Oh, that's gonna cause some wow, look at that. 100% across the screen. Is my stream doing okay? It's using every resource available. Oh my goodness. Do you think AI will automate humans out of their very existence? Hey, Jacob, I think humans will get to do human things. I think humans will get to do human things. We'll get to hang out. We'll get to eat food. We'll get to sleep. And the AI will just take care of us. Look at it go. I know, right? Isn't that neat? Look at it go. All right. I'm very excited with the amount of utility that we're getting out of this. This is very satisfying. This is very satisfying to see. I like it. I like it. So now I just need to form it to my will. We need to learn more. We need to learn more about it. we need to get better at the burn library. Stream seems fine for now. All right, great. I don't know how. How is that possible, right? Because every resource is fully consumed. The CPUs are pegged at 100%, as you can see there on the screen. So however that works, I guess. However that works, all right. Because we've got more than one stream happening at the same time, so I don't know however it works. All right, so that's actually kind of neat. Let's take a look at the loss. Let's see at the loss here. So we should be able to say a loose. Okay, so loss looking good there. Looking good. I like that. That is very nice to see. Learning rate. Oh, neat. So you can see these are each epochs, right? So each epoch it bumps and then it drops. It changes the learning rate over time. So high learning rate and then it tails off. High learning rate tails off. That's kind of neat. That's neat. Oh, hey, Nevo. Oh, this is always fun to see. Nevo, you're over there on Twitch. You came from YouTube. Yeah, I saw you, Nevo. You're over there on Twitch now. What are you doing over on Twitch? Yeah, we're trying to expand. Everyone on the stream was like, hey, you should try to stream on multiple platforms. Hey, how's it going, Apple? Apple R&B. What is going on? We are training an AI model to. This is optical character recognition, and it's already learned. It's already done great. I thought it was really neat. So what I want to do, though, is we need to transform the example into something that I could use. And we're trying to learn the Burn library. So at least we got something that works. At least we got some training. It didn't train my data. It's training sample data, which is, for tutorial purposes, right? It's for tutorial purposes. Jacob Crosby, realistically, AI will most likely push people into severe poverty, leading people to revert back to hunting and gathering. So AI doesn't so that wouldn't be AI that's doing it. That would be other humans that are oppressing other humans that are using AI to do so, right? An apocalyptic future where we have dystopian qualities, that would be a problem, right? We don't want that. We want a utopian future where the AI takes care of us, though. That's what we want. Jacob Crosby. By the way, wait, Nevo. Well, Nevo, what do you mean? What's the question marks for? Or wait, or you're sending question marks, but they're not actually question marks. It could be something that's not being encoded on my side properly. And so I'm not seeing what you're actually saying. Maybe you're sending an emoji or something across. So we've got the AI. It's training. It's doing what we want. Now we need to bend it to our will. That's what we want to do. We want to bend it to our will. In order to do that, though, let's see. Let's close that. Let's cd burn examples emnist. All right. So weird. What? LSSRC? So vi examples emnist. What's in this? Indie array run. This is all, got it. So this is looking for the feature config, and it's going to give us different backends. Got it. So you got Web GPU, Metal, Vulkan, and then you've got CUDA, right, for NVIDIA. And then whatever this is, I don't know what this is. What's ROCm? I don't know what ROCm is. The statement about AI replacing humans. Tell them it's just a program and it has no motives. You're right. Kyle, you're right. It's just a program. It doesn't have motives, desires, aspirations. It doesn't have any sort of future. It doesn't care. It's an oracle. It's an oracle. An oracle is able to have all the knowledge but not act upon it or have any motivation to do so. So AI currently is basically an oracle. Humans could leverage that AI to then do whatever they want with their own nefarious purposes if they want. Seems like 20 steps ahead of where actually tech is. It is a little bit of ways away, right? It is a bit away. Doggy style, crypto. Oh, I read it too late. Someone moderated it away. I read it. I read it. Whoops. Okay. All right. So, and then Torch GPU. All right. So libtorch backend. And then remote, where you could run it on another server, is what I'm assuming. Autodiff remote backend, so you can run it somewhere else. All right, so you've got all of these features. So that's what the example is doing. Run remote, run ROCm. I don't know what is this? What is ROCm? Burn ROCm. I want to know what this is. Let's see. Burn ROCm backend. What is this? What is the Burn ROC backend? I'm very curious about this. Burn ROCm backend is a specific implementation where the Burn deep learning framework Rust designed AMD's ROC software stack for high performance computing on AMD GPUs. That's what Vulkan is for, right? Isn't that what Vulkan is for? So here, check this out. I thought that's what Vulkan was. It's for AMD GPUs. All right, let's see. Let's ask the AI a little bit more. What about Vulkan? Vulkan. Is it Vulkan or Vulkan? Let's check here. VUL_C is Vulkan with an A. Okay. Isn't that AMD GPU? All right. So I'm just kind of curious. Maybe it's just a different. Yes, Vulkan supported backend for the deep, but can also be used with AMD GPUs in addition to RCOM backend. So what's the difference? This is a dedicated vendor-specific backend. So AMD's got their own thing. I didn't know that. So CUDA for NVIDIA and ROCm for AMD. Hey, the more we know. All right. Vulkan is specific with the web GPU and is a portable backend. Got it. Okay. It works everywhere, I guess. As a compatibility, broader support for a wider range of hardware, including AMD, Intel, and even integrated GPUs by relying on the Vulkan drivers. Got it. All right. So WGPU backend with Vulkan, sometimes different performance characteristics compared to the dedicated RCOM backend. All right. So RCOM is going to be faster if you can support it. ROCm will be faster if you have the capability to use it. Otherwise, WGPU will be faster for your system. For SAQ3000, how's it going? Welcome on in. Good to see you. Happy Tuesday. Hey, you're on multiple streams, SAQ3000. All right, I think we're good now. I think we're good on the training here. So let's go ahead and cue that. Stop training. All right, we'll let that go. All right, close that. There we are. All right. Neat. It's even got the progress bar and everything. So that's really satisfying. That's pretty neat. I like that. All right. So I'm into it. I like the Burn library. It comes with really good user interface, a good experience. We just need to get it to work for our own purposes. So, hey, how's it going? Mayua, we are training just sample data right now, and we're learning the Burn library. So we're learning the Burn library. We did pretty good. We're making progress. We're figuring small little things out, a little bit here and there. Is that BTOP or is that something else? It's something else. So the Burn library comes with a built-in a GUI, essentially, a GUI for your terminal, or a TUI, right? Terminal user interface. It's a terminal user interface. And it's very nice, isn't it? Isn't that nice? Doesn't that look great? You can see the progress, the percentage, the amount of time taken, the loss, the accuracy, the learning rate. Very, very satisfying to see this. And so all you have to do, though, is you have to write a whole bunch of boilerplate code in order to take advantage of it. And that's what we're trying to learn. The UI is nice, isn't it, Kyle? I thought it was nice. I think you might want to read up on how traits and iterations work in Rust. Yes. That sounds like a good one. That's a good... It would really help you with the boilerplate. It seems like it. It seems like it. You're right. I'm with you, Nevo. That would help a lot. I think you're right. Because when I'm using Rust, because I've been using Rust for many years, right? Half a decade at least, since 2019 or thereabouts, about 2019. I've dabbled with it before then, but I only really started heavily using it in 2019. So that's about 5-6 years. I've avoided a lot of the generics and other advanced capabilities of the language because I tend towards minimalism. Even in JavaScript or in Python, I don't like to use the advanced capabilities of abstraction. I like to avoid the abstraction, the capability of abstraction, because it adds a whole bunch more just text on the screen. And usually, for the most part, you don't need it. And I've been able to achieve it very well. Success without those things over many years. How's it going? And Schumann, good to see you. Welcome on in. Happy to have you here. Yeah, Rust is very C++ coded in this way, isn't it? It's like heavy abstraction, right? It's very heavy abstraction. Hey, the last attack, bro. I'm an RPA dev and shifting to AI agents. I know Python. Do I need to learn any other things? If you've got Python and you're doing AI, you're good. You're good, the last attack. You're good. Because you can use, basically, you don't need to worry about performance so much. Python comes with a pretty good binding capability with other libraries that are compiled. Rust can compile to a shared library that Python can import, and you can use it in Python, giving you the advantage of performance of all that work being done in basically a compiled Rust binary, and you can access it from Python. Same thing with C++ and libtorch with PyTorch, right? Exactly the same thing. Full stack Python dev. There you go. That's the way to do it. Full front end, back end, everything. Stephen, what you think about Jesus? In a way, like a man who had power to do anything literally. If you do, I'm just curious. I would focus on traveling the stars. I think that would be really neat. Let's expand the universe. The universe is massive. We're on the Earth right now. We haven't really gone anywhere else. I think I would like to travel the stars. I think, right? Isn't that's like that kind of the edit? Go to the heavens. C++ languages where there are a million different ways, and none of them are the best, right? Isn't it crazy? So a part of the thing is it's nice to have simplicity. That's why I really like simplicity. I'm building a model context protocol server. There you go. Nice. And Schumann. That sounds fantastic. I built one too. It's pretty straightforward. It's not immediately obvious, though it is pretty powerful. Do new features with AI platforms nowadays. I don't do much coding stuff. Is that fine? So the last attack, you're probably on the verge of being completely modern. You're at the state of the art. You're being modern. Milik, how's it going, Milik? Good to see you. Welcome on in. Hey, Steven. Good to see you. Is it more like PyTorch? So let me see here. I mean, it kind of, right? Most AI libraries are kind of like PyTorch is a lot easier to use. So if you're going to be looking for some AI libraries or frameworks, Python and PyTorch, pretty good. If you want an easier time, go to Keras and TensorFlow. Keras and TensorFlow are way easier. Much, much easier to deal with. Though PyTorch is going to be pretty much the industry standard at this point. It's simple, but a lot of things to do every day. I know, isn't it? It's got to learn, got to take care of business. There's just so much to do. There's so much to do. All right, you guys. So what we did today, I think we got some stuff going, although our code was just, my goodness. We're just trying to get something simple. Wouldn't it be nice to have a very simple Hello World example for the Burn library instead of this rather large, 400 lines of code that we need just to run the MNIST training data set? Seriously, the Keras, here, check this out. This is Keras. You're looking at this screen right here. Let me zoom out. Here you go. Here's all the code you need. 100%, you're looking at 100% of the code right here on the screen. Obviously, you can't read it because it's really small. Most of it is just text. But if you look at it, there's some code here, there's some code here, a little bit here, and a little bit here. That is the exact same thing that we're doing with the Burn library. And the challenge is, so you check this out. Look at this. Just take a peek at this. QK, all right. Watch this. LSSRC. All right, so see all these files here? This is ridiculous. All right, so let's see. CD SRC. Can I see what is that? WC star? Look at this. All right. Look at this right here. See, I told you it was 400 lines. I wasn't joking. It's more than 400 lines. It's 600 lines. 600 lines of code in the Burn library versus the Keras over here. You're looking at, I don't know, maybe 70 lines of code. It's like night and day. It's completely different. So that's what we're struggling with right now. That's our current struggle. You want me to write this example and send it to you? No, Nevo, that would be great. Do it. That would make my learning experience so much better. That would make it so much better. You should do it, Nevo. That would be great. Thank you. Thank you for doing that. Which is your favorite tool to use? Just Python? Python's my favorite. When I feel tired, my favorite is Turtle. Is it Turtle? Oh, favorite library? The Turtle library in Python? I remember the Turtle library. I remember that. Hi. Oh, hey, Drawing Brothers. Good to see you. It's been a long time. It's been a little while. It has. How's it going? Good to see you. We're just playing with the Rust torch library, or the Burn library basically, in Rust, and we're trying to learn it while complaining. Sure, IG, I would know to do that. Okay, are you in Discord, Nevo? Are you on the Discord? So then just paste it over here to the Discord. You can DM me or send it under like a link on the free resources. Like that would be phenomenal. Nevo, that would be great. That would be so great. Thank you for doing that. I would love to see that. And then we can walk through it on stream. That way we can walk through it on stream. So I'll read it live on stream. We'll look through everything that you're doing. Why are you learning Rust? Milik, so I've got an okay understanding of Rust. I've even done a full training course on Rust. So if you like it, Stephen Blum Rust by example. So if you got a giant playlist of Stephen Blum videos here. So like a whole bunch, right? And these are all Rust. They're all Rust. And we've got like a lot. We've got like a lot of videos on Rust because we've done it before. It doesn't mean that it's easy still. Like even after all of that, I don't know where the Discord is. Okay, here I'll paste it to you, Nevo. 1 second, Nevo, just for you, Nevo. The Discord's on the way. 1 second. All right, we're sitting over the Discord. 1 second. Let me grab the link here. All right, clicking the link. Edit invite link. All right. Never, no limit, create, copy. Okay, here we go. We'll send it on over, Nevo. Here you go. Paste that in. Here we go. There is a link to our Discord. There you go. All right. Studio. All right. So for those who are interested, let me click here. We'll paste in a link here to our Discord. Let me see. So here you go. We also have a hackathon running on Int on Sunday. That's right. We do. Thank you for the reminder, Torva. Hackathon. And it's here in our channel. All right, let's go over here. Hackathon. All right. So here it is. Simulate a 4x4x4 CPU in a normal 2D programming environment. All right, a normal 2D programming. Because the CPU is in a third axis, each cell doesn't normally use normal binary bits. Instead, every cell can take 3 states. Trinary. Or trits? Wait, is that what that's called? Trits? It's not trinary, it's trits. Oh, bits and trits. Weird. All right. So a bit or a trit. So it could have 3 states. 3 states, what do you know? That's pretty neat. So, yeah, the hackathon, and it's supposed to end on Sunday, you said. Which hackathon? Raj Kumar? Raj Kumar, it's here in our Discord. So I just pasted the Discord link, and here's the hackathon. And there you go. There you go. DM Torva on Discord for additional details if you have any questions. There you go, you guys. There you go. So it's great to hang out, everyone. We had a lot of fun today. We got things kind of working. I didn't succeed as much as I wanted to, although I'm actually pretty happy that, we got something built. We've got a known good working example, and Nevo is going to write for us a very simple Burn library or Burn implementation of cool. SAQ 3000. Cool. See ya. Yeah, we're headed out now. I had to look it up. What they sound pretty weird. Do they? Gotcha. Just a smidgen weird, right? Just a little bit of weird. All right, everyone. Thank you so much for hanging out with us today. We'll be back tomorrow. Errors are the steps towards success. You got it. That's right. It's all about learning, and you make mistakes, and then you learn from those mistakes. Mistakes are often misconstrued as a total failure and a problem. Yeah, technically, it's a failure. However, you've learned, and so you've made progress, and that's part of the struggle. You have to fail, and in your failure, you learn. If you don't fail, you're not really learning, right? If you don't fail, you're not really learning. So that's one of the problems with the AI is you go to the AI and you succeed immediately, which is probably okay, isn't it? Do we really need to be smart anymore if we have a smart machine to take care of us? I mean, that sounds kind of nice to be able to just kick back, eat some food, play video games, and go to sleep and not have to worry about anything while the AI just takes care of everything. You don't need to be smart anymore. So there you go. All right, everyone. Thank you for hanging out. We'll be back tomorrow. Nevo, I'll chat with you on Discord, and then we'll see if we can, whatever you come up with, we'll read live on stream tomorrow. Sounds good to me. All right, everyone. Thank you very much for hanging out with us. We'll be back tomorrow. And we'll be doing more Rust and the Burn library. See you guys. Have fun. Be back tomorrow. Elon said work would be optional. That's right. It's optional. It's like Star Trek Society, right? It's the Star Trek utopian future where work is optional. If you want to work, you can. Only if you want to, though. What thought on that? Yeah, it's the Star Trek Society. It's not original idea. Elon definitely not come up with it on his own. That was the whole Dolly. Yep, you're right. Dolly movies. Underlying theme. You don't have to work anymore. You just enjoy. Just enjoy being human. Oh, dear attendees, we shall thank you all for gifting us with your presence. Torva, thank you. It shall be bestowed upon us tomorrow once again. Yeah. There we go. All right, you guys. Thank you so much. We'll be back tomorrow. See you guys. See you guys tomorrow. Bye, guys. I'm clicking the end stream.